Welcome to the DIY Honda Garage channel. Welcome to the diagnostic presentation on DTC P0522, which stands for Engine Oil Pressure Sensor Circuit Low Voltage, specifically related to Honda Accord models manufactured between 2017 and 2023. This error indicates that the engine oil pressure sensor is sensing a lower voltage than the expected threshold. The engine oil pressure sensor is crucial for monitoring the oil pressure within the engine, ensuring that the engine is properly lubricated and functioning optimally. When the pressure drops below the required level, it can lead to serious engine damage. In this presentation, we will explore the components involved, potential causes for this error code, and the systematic steps required for troubleshooting and repairing the issue. The DTC P0522 directly involves the engine oil pressure sensor and the powertrain control module, commonly referred to as the PCM. The engine oil pressure sensor is located near the engine block, typically positioned above the oil filter or in the oil gallery. It plays a critical role in monitoring the oil pressure, sending real-time data to the PCM. If the sensor detects low voltage, it implies that the oil pressure may not be adequate for proper lubrication of engine components, leading to potentially serious engine issues, such as overheating or premature wear. The PCM receives signals from various sensors and uses this information to adjust engine performance. In this case, low voltage readings indicate either a malfunctioning sensor or an issue in the electrical circuit between the sensor and the PCM. There are several possible causes for the DTC P0522. First, a faulty engine oil pressure sensor is the most common reason, where the component may no longer provide accurate readings due to internal failure. Second, an open circuit in the VCC2 wire, which supplies voltage to the sensor, can prevent the correct voltage from reaching it. This could be due to physical damage to the wire or poor connections. Third, a short circuit in the op-sen wire may also be responsible for low voltage readings, overloading the sensor or leading to incorrect functionality. Each of these conditions requires careful inspection and testing to determine the root cause and the appropriate steps for repair. Symptoms associated with the DTC P0522 can manifest in various ways. Initially, drivers may notice warning lights on the dashboard, indicating an engine issue or oil pressure concern. If the issue remains unaddressed, there may be a risk of engine overheating due to insufficient lubrication, leading to severe engine damage. Additionally, poor engine performance can result from disrupted oil pressure levels, affecting overall efficiency and drivability. It is crucial to pay attention to these symptoms, as they serve as indicators that further investigation is necessary to protect the integrity of the engine. For the first troubleshooting step, ensure the vehicle is turned to the on mode. Utilize the HDS or Honda Diagnostic System to check the parameters, specifically the rocker arm oil pressure signal. Monitor the voltage. Values equal to 0.18 volts or less signify a potential problem. If these current conditions match the threshold, your findings confirm a failure, prompting you to proceed to the next step. However, if the conditions do not match, it may suggest an intermittent failure, which could imply poor connections or loose terminals at either the engine oil pressure sensor or the PCM. In such cases, inspect the physical connections and try to duplicate the issue under the same conditions to confirm it. For the second troubleshooting step, begin by turning the vehicle to the off or lock mode. Next, disconnect the 3P connector for the engine oil pressure sensor. With this connector removed, turn the vehicle back to the on mode. Once again, utilize the HDS to check the parameters for the rocker arm oil pressure sensor voltage. The threshold remains 0.18 volts or less. If the current conditions match this threshold, move forward to the next step. If they do not match, it indicates that there could be an issue within the engine oil pressure sensor itself, prompting a more in-depth examination. During the third troubleshooting step, ensure that you measure the voltage between two specific test points, while the engine oil pressure sensor 3P connector remains disconnected. The vehicle should be in on mode during this check. Test point 1 corresponds to the engine oil pressure sensor connector's female terminal number 1, while test point 2 pertains to female terminal number 3. If the voltage reading is approximately 5.0 volts, this indicates the wiring and connector are functioning correctly. If the readings do not meet expectations, it is likely time to replace the engine oil pressure sensor, as it may no longer accurately relay vital information needed by the PCM. In the fourth step, you'll start by turning the vehicle to the off or lock position. Use the HDS to jump the SCS line and wait over 1 minute to ensure proper initialization. After this, disconnect the ADP connector from the PCM. Now check for continuity between the specified test points while ensuring the engine oil pressure sensor 3P connector is also disconnected. Test point 1 is found at terminal number 3 of the engine oil pressure sensor connector, while test point 2 corresponds to number 77 on the PCM connector. If continuity is present, it confirms that the VCC2 wire is functioning, and further investigation into symptoms or other DTCs may be prudent. Conversely, a lack of continuity suggests an open circuit, necessitating repairs to the VCC2 wire between the PCM and the engine oil pressure sensor. In the final troubleshooting step, begin again by turning the vehicle to the off position. Once more, utilize the HDS to jump the SCS line, waiting for over a minute. After doing so, you will disconnect the PCM connector E, ADP. Similar to previous steps, check for continuity. This time between test points, where test point 1 refers to female terminal number 2 at the engine oil pressure sensor connector, and test point 2 leads to body ground. If continuity is found, this indicates that the OPSN wire is shorted, which will require professional repairs of that specific wire between the PCM and the engine oil pressure sensor. If continuity does not exist, it suggests the OPSN wire is intact. However, further examination may still be necessary to confirm PCM functionality or access additional technical resources. After completing all the troubleshooting and necessary repairs related to DTC P0522, it is vital to conduct a final verification of the repairs. This involves rechecking the vehicle for any stored diagnostic trouble codes, DTCs, to ensure that P0522 has been resolved. Following this, a test drive should be performed, allowing the vehicle to reach normal operating conditions. During the drive, closely monitor oil pressure readings through the HDS to ensure they remain within acceptable parameters. This step is critical to confirming not only that the specific issue has been rectified, but also that related systems are functioning adequately. If problems persist, further investigation may be warranted. Conducting routine preventive maintenance is essential in mitigating future occurrences of DTC P0522. Regular oil changes, following manufacturer recommendations, ensure that the engine maintains optimal lubrication and reduces wear on sensors and components. Along with this, periodic inspections of the engine oil pressure sensor and related wiring can help detect potential failures before they escalate into larger issues. It's also helpful to routinely check electrical connections for signs of wear, corrosion, or looseness, which can be problematic. Establishing a consistent maintenance routine not only helps prolong component life, but also enhances vehicle reliability and performance. In conclusion, DTC P0522 highlights a critical issue regarding the engine oil pressure sensor circuit and lowered voltage levels. Understanding its implications and the components involved, namely the engine oil pressure sensor and the PCM, is vital for addressing potential engine issues effectively. Throughout the troubleshooting process, we examine systematic checks, from verifying signals to identifying both shorted and open wires in the circuit. The importance of preventive maintenance is also a key takeaway, ensuring that regular checks and timely oil changes help in avoiding such problems in the future. Keeping these elements in mind will lead to a well-functioning and reliable vehicle. Please like and subscribe to the channel. See you next time.